Hello, this is Mia Wood, Associate Professor of Philosophy at Pierce College. Today we're going to talk about the rule negation intro. More specifically, we're going to talk about how you use this rule to structure your derivation. As you become more proficient in dealing with more complicated derivations, you will often use negation intro within an existing subproof. In other words, you'll use it in a nested subproof, but today's focus is on how you structure your derivation. We will also look at the connection to the truth functionality of the rule, and we'll look at some examples, two of which will use conditional elimination, and that may be a rule with which you're not familiar, but it's pretty intuitive and it will not undermine our presentation. So it should still be the case that you understand why you use negation intro and how you use it. This is a screenshot taken from our textbook. You'll notice there are two lines. The vertical line on the left is the main spine or main line of any sequence. It may also be a subproof sequence, but again, I'm focusing here on the rule as it applies to structuring your derivation. So let's take the line on the left as the main line. And then the second vertical line to your right is the subproof line. Just above the Fitch bar is the assumption P. So that stands for, as you know, kind of any sentence in the universe, any assumption that you make. From that assumption, you will derive a contradiction. So below the Fitch bar, you see those three dots, one on top of the other. Those just stand for however many lines it takes to reach your contradiction. And the contradiction in this rule is the end of the subproof. So from the assumption P, you derive a contradiction. The subproof then ends. That's it for that subproof. You then get out of the subproof and say, effectively, that assumption is not the case. Let's go ahead and look at a straightforward informal example, and then we'll go back to the rule form and see how it relates to truth functionality. So I call this the "you lied to me" example, and it goes like this. For 2 weeks, Lovey-Dovey has been calling home every night from her cell phone saying that she's got to work late. She says she's calling from her cell phone because the phone in the conference room where she's working is on the fritz. And since her office is 10 flights up, it's just easier to call from her cell instead of going up those 10 flights to use her office phone. But you're suspicious. She comes home smelling like cheap cologne or perfume. You can't really tell which, you just know it's cheap. Unfortunately, but not surprisingly, when you ask her straight out if she's having an affair, she denies it. So you decide to do some investigating and see for yourself. A week later, you confront her. I checked your cell phone records, you say. For the past few weeks, you claim you've been calling from the conference room at work, but your cell phone records show pinging from another location 15 miles away. The easy peasy sleazy hotel. You can't have been at work and not at work at the same time, so you lied to me. Okay, it's a little dramatic, but you get the idea. Now let's take a look at the truth functionality of the idea of a contradiction. Here's a straightforward argument. P disjunction Q, not P, therefore Q. You already know as well that 2 atomic sentences yield 4 rows of a truth table. You also know the truth definitions for the disjunction and the negation. Take a look at each of the rows. The premises, P or Q and not P, are true at the same time on row number 3, but the conclusion is also true on that row. Now take a look at the rows where the conclusion is false. Notice that in each case where the conclusion is false, at least of the premises is also false. In other words, the argument is valid. There is no row on which the premises are true while the conclusion is false. What if you decided that you were going to assume the argument is invalid? Take a look at what we have here. We've assumed the argument for which we just constructed a complete truth table is invalid. We're assuming that the disjunction is true, the negation is true, and the conclusion Q is false. In other words, instead of building up to or calculating up to our connectives, we are assuming that connectives are true while the conclusion is false. What we're going to do is work backward. In other words, if Q is false, you plug F under the Q in the first premise. And then in order for the disjunction to be true, that means P has to be true. But take a look at the second premise when you do this. Take a look at the literal. It's said to be true. But take a look at P. It's also said to be true. In other words, there's a contradiction. Not P and P can't be true at the same time. By assuming that the argument is invalid and then working backward, we have shown that the argument can't be sustained as invalid. Now let's look at a worked example. Premise 1 says, the dog will be adopted or euthanized. Premise 2 says, I can't let the dog be euthanized. In other words, the dog won't be euthanized. Therefore, sentence 3, the dog will be adopted. Okay, so here we are in a Fitch window. I've gone ahead and typed the premises and the conclusion into an untitled screen, an untitled page. And you can see that we have a disjunction. We could use disjunction elimination in order to prove the conclusion. And in fact, we will use disjunction elimination. But remember, this tutorial is about using negation intro. So we're going to set up negation intro in the standard way. It's not the only way, but it's the standard way. It helps get us thinking about structuring our derivations. We're going to assume that the conclusion is false. We'll derive a contradiction so that we can get out and say that it's not the case that not A. Now, we know that when we introduce a negation, if there is an existing negation, in other words, if the assumed sentence is negated, is a literal, then when we get out of our subproof, we introduce a second negation, but Fitch doesn't require that we do that, so we can just go straight to the affirmed sentence. Okay, so you can probably see now two implicit contradictions. We've got the left side of the disjunction at line 1, the assumptive literal at line 3, and then we have the right side of the disjunction at line 1, and then the negated sentence at line 2. So we know that when we have a disjunction in our premises, 99 times out of 100, we are going to have to use disjunction elimination. So let's go ahead and use that now. We need it. We're going to assume the left side of the disjunction. That allows us to assert then a contradiction. We can get out and assume the right side. That allows us to, once again, assert a contradiction, which then allows us to get out of the disjunction elimination subproof and say, look, from either side of the disjunction at line 1, we generated a contradiction. Therefore, in either case, we have a contradiction. Now, I ran through the actual derivation pretty quickly at first, because remember, the point is to show how we the point is to show how we set up our derivation using, in this case, negation intro. So when we set up our derivation, what we did was we said it's not the case that the conclusion is true, and then we derived a contradiction per the rule, and we were able to then get out, and that step checks out. Another point to make here is that, in fact, you could go ahead and justify the conclusion before you even start the derivation, so that you know what it is that you're doing, how you're setting things up. With longer proofs, this allows you to not sort of get lost and forget where you're going. I mentioned also that you do use the disjunction elimination subproof in order to achieve your conclusion. Remember, though, when you're using a nested subproof, that the whole point of the nested subproof is to allow you to achieve a sentence that is going to get you back onto the structuring subproof line, in this case, line 8. Let's go ahead and cite and justify each of our steps. Line 5 is justified by contradiction intro. Remember, this is a truth functional contradiction, and the citations are lines 3 and 4. Line 7, justified by contradiction intro. Again, a truth functional contradiction intro. That is, you can't have E and not E be true at the same time. So you end up with lines 2 and 6 generating that contradiction. And don't forget the idea of the contradiction we looked at in terms of truth functionality, right? So if your argument is valid, but you assume it's invalid, and that's just what we've done here. We know that the argument A or E, not E, therefore A, is valid. But by assuming not A, we're pretending that the argument is invalid. And as we saw with our indirect truth table, that yields a contradiction. Okay, so line 8 is not a contradiction intro, right? Notice that line 8 is the result of the disjunction elimination, right? We had the disjunction at line 1. We assumed the left side, generated a contradiction. Assume the right side, generated a contradiction. That allows us to then get out and say, look, in either case, right, by eliminating by way of assumptive proofs, successive assumptive proofs, the disjunction at line 1, we get the contradiction. All right, and everything checks out. As I mentioned just a little bit ago, I'm going to give you a couple of examples from outside, if you will, our class. This one comes from Carnegie Mellon University, and I just think it's fun, so I wanted to use it. Plus, it's really straightforward, but it's one of the two examples I mentioned that will use the conditional elimination rule, which you may not have yet learned. However, you'll still find that the examples are pretty straightforward. So in this example, we have the following argument. The premises are represented by what Kant and Hilbert say, and Socrates gives us the conclusion. Kant says, if we don't have ice cream, then I'll buy it. Hilbert says, if you buy ice cream, then we'll have it. And Socrates concludes, yay, we'll have ice cream. Let's go ahead and look at this argument and the proof for it in Fitch. Okay, so here on your left, you see a Fitch window. I've typed in the argument. You have two premises, negation I, conditional B, premise 2, B, conditional I, and the conclusion I. So we have, if we don't have ice cream, then I'll go buy it. If I buy it, then we have it, so we have it. But let's assume that we don't have it. Let's assume that it's not the case that we have ice cream. What are we going for? A contradiction, so that we can say our assumption is in fact false. So what we're setting up, remember, is negation intro. So what's going to generate that contradiction? Well, it looks like we have an implicit contradiction in the antecedent, or the left side of the arrow, on line 1, and the consequent, or the right side of the arrow, on line 2. Now, if you're not familiar with conditional elimination, not to worry, it's pretty straightforward. Take a look at lines 1 and 3. Line 1 says, if not I, then B, and line 3 says, it's not the case that I. In other words, line 3 affirms the left side of the arrow at line 1, which allows us to dismantle that arrow. So we're going to cite lines 1 and 3, and the rule we're using here is conditional elimination. We're going to do the same thing at line 5. Take a look at lines 2 and 4. If B, then I, it is B, therefore it's I. Same rule, the elimination of the conditional. Now take a look at line 6. What's the contradiction that we're expressing? Well, lines 3 and 5 can't be true at the same time. They are contradictory. So we assert the rule. Let's go ahead and check that out. We can go back and check out line 5 as well. Now, is it the case that once we've generated the contradiction, we're allowed to get out of the proof, the subproof, I should say, and deny or reject the assumption at line 3? It is. Now we have an example from the 1992 film A Few Good Men. There are some really great argumentation sequences in this film. This one that I'm about to show you is one of my favorites. If the audio is a little out of sync with the picture, I apologize, but focus on the language, not on the syncing.
A moment ago, you said that you ordered Lieutenant Kendrick to tell his men that Santiago wasn't to be touched.
That's right.
And Lieutenant Kendrick was clear on what you wanted?
Crystal.
Any chance Lieutenant Kendrick ignored the order?
Ignored the order?
Any chance he forgot about it?
No.
Any chance Lieutenant Kendrick left your office and said, the old man is wrong?
No.
When Lieutenant Kendrick spoke to the platoon and ordered them not to touch Santiago, any chance they ignored him?
You ever served in an infantry unit, son?
No, sir.
Ever served in a forward area?
No, sir.
Ever put your life in another man's hands? Asked him to put his life in yours?
No, sir.
We follow orders, son. We follow orders or people die. It's that simple. Are we clear?
Yes, sir.
Are we clear?
Crystal. Colonel, I have just one more question before I call Airman O'Malley and Airman Rodriguez. If you gave an order that Santiago wasn't to be touched, and your orders are always followed, then why would Santiago be in danger? Why would it be necessary to transfer him off the base?
Santiago was a substandard Marine. He was being transferred.
Not what you said. You said he was being transferred because he was in grave danger.
That's correct.
You said he was in danger. I said grave danger. You said, is there
I
any
recall
other...
what I
I
said.
can have the court reporter read back to you.
I know what I said. I don't have to have it read back to me like I'm...
Write 2 orders. Colonel?
Sometimes men take matters into their own hands.
No, sir. You made it clear just a moment ago that your men never take matters in their own hands. Your men follow orders or people die. The core dialogue that we want to focus on for the purpose of demonstrating setting up your derivation using negation intro is this question necessary to transfer him off the base. I've rewritten the argument this way. It's a little bit fleshed out so that we can see the structure of it more clearly. If Colonel Jessup gave an order that Santiago wasn't to be touched, and Colonel Jessup's orders are always followed, then Santiago would neither be in danger nor need to be transferred off the base. But he was in danger and needed to be transferred. So, either Colonel Jessup did give the order to rough up Santiago, or Colonel Jessup's orders aren't always followed. And of course, we know where this is going. In either case, Colonel Jessup, who's been backed into a corner, is in big trouble. Here's the basic setup. We're going to turn to Fitch in just a moment to look at the thing played out. T stands for Santiago was touched. In other words, Santiago was roughed up. O stands for Colonel Jessup gave the order. D is that Santiago is in danger, and R is Santiago needs to be removed from the base. So we have 2 premises, and then line 3 starts the structuring subproof. And what I've done is made the assumption at line 3 that the conclusion is false. Let's see how this plays out in Fitch. Okay, so I've opened up a Fitch page. I've typed in the premises and the conclusion of the
a few good men argument, what we're going to do is set up our proof by way of negation intro. In other words, we're going to use negation intro to structure our derivation. A standard way to do that is to take the conclusion and to negate it, to say the conclusion is not the case. Then what we do is derive steps until we've achieved a contradiction so that we can get out and say that the assumption is false. So now the question is, how do we dismantle the connectives at lines 1 and 2 so that we can generate that contradiction? Well, there are several ways that we could go about doing this, and I'm not really interested in worrying over which is the best way, as long as it's legal and as long as you stay within the constraints of whatever instructions you're given, like whether or not you can use TautCon. Really, our plan here is to show how you generate a contradiction to show that your structuring subproof, in this case negation intro, works.